Autonomous AI agents have been the hottest topic. It is truly impressive how rapidly things have progressed and unfolded in this area. Even AI experts, including Andre Karpathy, referred to AutoGPTs as the next frontier of prompt engineering. I think so as well. What do you think? There are at least 4 notable autonomous AI agents projects that just came out in the last 2 weeks. In this video, we're going to dive into each of them. First up, we have the Westworld simulation. The original paper's name is Generative Agents, but people have been calling it Mini Westworld or Westworld simulations. So researchers from Google and Stanford created this sandbox of 25 AI agents that can interact with each other and simulate human behavior. You can click on the agent and to see where they are and what they're doing right now. This agent, Tamara, is doing certain actions. Let's pause it so we can see exactly what she's doing. She's having a conversation and discuss their creative projects, local politics. It looks really real, and the current conversation looks really real as well. Let's go to the original paper of the generative agents. As you can see here, the agents can take a walk at the park, share news with colleagues, arrive at school. They can simulate believable human behavior, not just fake behaviors, but those behaviors are actually believable. What's more impressive is that they can even plan a Valentine's Day party with everyone together. Here you can see the description of the Valentine's Day party, starting with only a single user specified notion that one agent wants to throw a Valentine's Day party, spread the invitations to the party over the next 2 days, ask each other out on dates to the party, and coordinates the party. This is really impressive. So how is this all possible? So this is all possible because of the generative agent architecture. There are 3 most important components in this architecture: memory, reflection, and planning. The memory stream contains a list of observations for each agent at each timestamp. So you can see here's just a log of all the observations, whether it is behaviors that's originated by the agent or the behaviors that the agent perceives from others. As you can see, the memory stream here can be really long because it's just logs. We need to figure out which memory is kind of important. Just think about it as human beings. We have a lot of memories in our long-term memory system, but we can't recall all the memories, right? We can only remember the important ones or the most recent ones. That's exactly how this memory system is working in terms of retrieval. For each observation, there's a retrieval score, which is a combination of recency, importance, and relevance. Recency tells us that the most recent memories are more important, and then for importance, it's the memories that the agent believes to be more important to have a higher score. For example, if you break up with someone, the memory should be more important than having breakfast this morning. And the relevance is how relevant this memory is to the current situation or the current query. So this way, you can retrieve your memory based on the retrieval score and only retrieve a subset of the memory with higher retrieval scores. The second important component is called reflection. When you are only looking at raw observations, it's really hard to generalize and make inference. As you can see here, we have a bunch of observations, and those can contribute to different reflections over here. Reflections are higher level, more abstract thoughts generated by agent. It is generated periodically, not all the time, of course. It's using basically, I think, just 2 questions. Given only the information above, what are 3 most salient high-level questions you can answer about the subjects in the statement? And the second question, what 5 high-level insights can you infer from the above statements? So that's the reflection, high-level abstract thoughts by the agent. The third important component, as we said before, is planning. Planning is important because you don't want your agent to do the same thing over and over again. For example, class would eat lunch at 12, but then again at 12:30 and 1 p.m. With planning, you're planning for a longer period of time so that your sequence of actions can be coherent and believable. So planning is essential. And now, of course, you can react and update your plans according to other observations in the memory system. So yeah, so that's the Westworld simulation. We have observations in the memory system, retrieve relevant memory, and then we act based on the relevant memory here. And also you reflect, you make plans and reflection also fit into the memory system. It's like an infinite loop over and over again. The possibilities for applications for this is kind of huge. This is kind of a big deal and maybe even a little scary. Just imagine if there is an agent that watches and observes your move every day. It can make plans for you and even perhaps execute plans for you. For example, the agent could know when you would get up and help you make your first cup of coffee. So this is like so scary and so useful at the same time. LangChain is actually actively working on this right now. So hopefully in the next week, we'll have something to play with in LangChain. I'm looking forward to that. Yeah, so that's the first project I think you should know. The second project I want to talk about is called Camel. Communicative Agents for Mind Exploring of Large-Scale Language Model Society. Similar to the generative AI we just talked about, this one also uses more than one AI agent, where the two AI agents communicate and interact with each other. Camel proposed a role-playing framework with two agents, where we have a AI user agent and a AI assistant agent, where AI user agent gives instructions for completing a specific task, and the AI assistant agent provides solutions for the task. There's also another agent called Task Specifier to brainstorm specific tasks for AI user and AI assistant to complete. As an example, a human user has an idea of developing a trading bot for the stock market. Then the task specifier comes up with a specific task. It's going to develop a trading bot that can monitor social media platforms and execute trades based on sentiment analysis results. So this agent is actually really helpful because you don't really need to come up with specific ideas and steps to feed into the language model. You only need an idea and this agent will generate specific tasks for you. And then with this specific task in mind, AI user actually becomes the task planner and the AI assistant agent becomes the task executor. They actually prompt each other in a loop until some termination conditions are met. The essence of Camel is actually the prompt engineering. They call the prompt inception prompting. Here are specific prompts that Camel is using for the assistant and for the user. The wording has its specific uses. For example, never flip roles is preventing agents from flipping roles. And then there are some wording prohibit the agent from producing harmful or misleading information. And then there are some prompt to make sure the assistant always responds in a consistent formatting. And then your solution always ends with the next request so that the conversation can keep going. Let's take a look at the LangChain implementation of Camel, which was just released this week. So first of all, we install needed packages, LangChain and OpenAI. We import the needed packages. By the way, I will link all the Colab Notebooks that I used today in the description below. If you need it, you can take a look. We define a Camel agent helper class. Okay, so this is the thing we actually need to set up ourselves. We need to set up OpenAI API key, so type your keys here. You need to give the assistant agent a role name. Here in the example, we have Python programmer. You need to give the user agent a role name, stock trader in this example. And then you need to specify a task. The example is develop a trading bot for the stock market. So then you need to create a task specify agent for brainstorming and getting the specific task. Here is the task specifier prompt. Here is a task that our assistant will help the user to complete. And the task is actually develop a trading bot for the stock market. Yeah, so you actually don't need to change anything here. It's ready to go. And then we have the inception prompts for AI assistant and AI user for role playing. and those wording are just the same as the wording in the article I just showed you. More helper functions, and now we can create a assistant agent and a AI user agent. And then finally, you can start role-playing session to solve the task. As you can see, it's basically just a while loop, right? If you set the chat turn limit, which is like the number of conversations, really high, it can go on forever. But I just set it as 5 because I don't want to spend too much money on it. And also, by the way, I just learned that GPT 3.5 Turbo is cheaper than GPT 3. So yeah, keep that in mind when you set this up. Okay, let's take a look at the result. The original task prompt is we are developing a trading bot for the stock market. And now we have a specified task prompt. Create a Python-based trading bot using real-time market data. Analyze historical data trends and implementing risk management strategies. Okay, it's a little different from the example, but also I think it makes sense. The AI user agent, which is the stock trader, gives an instruction, install the necessary packages for the trading bot. The AI assistant then provide a solution to install some packages, create a requirements.txt file, list it, and that list all the requirement packages, which makes sense, but it didn't say which packages are required in the requirements.txt file. So it's not perfect actually. And then the AI user give another instruction of connect to a real-time market data source. The AI assistant then went to this website to get the data. Is this a real website? Okay, this is not sure if it's real or not. Maybe it is, it just need API key. And then we have implement a function to track portfolio performance by calculating the total value of all stock currently held. And now we have a track portfolio function. So one issue about this is that you can see all the responses are from the large language model. It's actually not executing the Python code. It's not using any tools. It would be nice if we're not only generating the Python code as text, but also we can actually execute and run the Python code. And if it doesn't run, then we debug and keep trying until it works. That'll be very nice. So I'm hoping LangChain will integrate all the amazing tools to use with Camel. Then it will definitely give Camel more power to connect it with different tools. There are some interesting use cases that I saw on the internet. This is, I think, the developer of Camel. So yeah, so he actually asked Camel to take control of the world. AI user and AI assistant was able to make a plan to infiltrate the communication networks, take over the financial infrastructure, political system, defend AGI's operations in space from operational threats. Yeah, so there could be some really scary stuff out there, potentially. Anyways, this is Camel. I actually really like this one because it's so fun. It's just 2 agents talking with each other. Yeah, that's the second project. The third project is BabyAGI. You probably already heard about it or have even tried it. I just love the name BabyAGI so much. It's so cute. I think it's a really good choice of the name. This is the BabyAGI documentation. It's actually written by GPT-4. It's very interesting. Unlike the previous 2 projects where we have multiple agents interact and communicate with each other, BabyAGI only has 1 AI agent with 3 task agents. So this one AI agent doesn't communicate with other agents, but instead the task agents, they are kind of work together in a loop to create tasks in a to-do list, to execute tasks and reorder the task. The author Yohei mentioned in a webinar that BabyAGI works exactly how he works actually. He would start each morning by working on the first item on his to-do list. When there are new items or new tasks arise, he would add those to his to-do list, and then by the end of the day, he would reevaluate and reprioritize the tasks in the to-do list. So he then mapped the same approach to the task agents for BabyAGI. So basically we have a task queue. The user will provide the objective and the task. The task execution agent will complete the first item of the task queue. The task creation agent receives the task result and also have the context from the memory and then create a new task. And finally, task prioritization agent reprioritize the task and return the cleaned task list. And then this process just gets repeated over and over again. Let's take a look at the LangChain implementation. We install needed packages, and then we import needed packages. You need to type in your OpenAI API key here. We connect to the vector store. Here we're using Fias, but there are other options. You don't have to use this one. You can choose other vector stores you like. Now the important parts are the three LLM chains. The first chain is the task creation chain. You can see the prompt here. You are a task creation agent that uses the result of an execution agent with the following objective. You see the result of the previous completed task. And now, based on the result, create new tasks to be completed. For the task prioritization chain, you would clean the formatting of and prioritizing the following tasks. Return the result as a numbered list. And then the execution chain would perform one task based on the following objective. Take into account previous completed tasks and execute your given task. So those are the three task chains. And now to define BabyAGI controller, we have a while loop here. Looks familiar. We pull the first task, execute the task, store the result. Actually, we were using Fias, so that should be Fias. And step 4 is to create new tasks and reprioritize task list. So it will stop if we give it a max iteration number and if the number of iterations is the maximum of the iteration that we set. Here's an example. Write a weather report for San Francisco today. Our first task is to make a to-do list. Makes sense? And now we execute this task. The result is a to-do list as we expected. Check the current temperature in San Francisco. Check the forecast of the day, which all makes a lot of sense. Now we get a new task on the top. Check the current temperature in San Francisco. Now the current temperature is 57 degrees Fahrenheit. This is actually not correct, by the way, because this is just a language model. It doesn't actually know the real temperature right now. And also, because I only ran 3 iterations, it didn't actually get to write the report part. But that's the basic idea. You can see it's actually important to include different tools to work with BabyAGI together so that the information can be more accurate. In this next example, I tried a BabyAGI with LangChain tools. It's actually integrated with LangChain tools already. We need to pip install Google search results so that we can do Google search. We need to provide the SERP API key, again, to do Google search. There are 2 code chunks that are different. The first one is to define tools we use. Here we define a search tool to answer questions from Google search. Another tool is the to-do chain, which is useful for making a to-do list, I guess. When we define the BabyAGI controller, we need to define the tools in our agent. Here's the same write a weather report for San Francisco today. As you can see, it uses Google search to search local weather stations, current temperature in San Francisco, and it was able to get the current temperature. This one is interesting. It came up with a new task to compare current weather condition to historical data. We didn't ask for historical data at all, but it was able to come up with this comparison because a weather report would be nice to have some comparisons. The next one is a little weird. I think it has a good idea, but we didn't give BabyAGI enough tools to make this visual representation. It kind of didn't go well. So on the LangChain website, actually give us a little better result. You can see it's actually kind of pretty comprehensive and nice. There are actually a lot of real-world use cases on this already, which is quite impressive. This project that can write code and execute code. And here we have Agent GPT, which is also very popular. It's AutoGPT in the browser, BabyAGI ChatGPT plugin. And we have an example of BabyAGI in Slack. This is a BabyAGI on Discord. Scientific literature reviews. Yeah, so that's BabyAGI. And the final project we have today is AutoGPT. AutoGPT is a lot like BabyAGI, but with its own framework and its own set of tools. It's also an infinite loop of generating thoughts, reasoning, criticizing, planning the next action, and executing. One thing special about AutoGPT is that it comes with a set of tools, and it's not in the LangChain framework yet, but hopefully soon it will be in LangChain. So I want to show you the tools it has. You can run many different commands using AutoGPT. Start agent, message agent, list agent, get text summary, read file, write to file. I'm not sure if LangChain has the tools to read and write to files, and also search files, browse website, evaluate code, write tests. Yeah, so this is quite nice. And when you look at exactly what's under the hood here, this goes to another function. So this is basically a function of how to get result from Google search. And those are all functions that you can craft and adapt to your own use cases, which is, I think, provide a lot more flexibility for you if you would like to use it. LangChain is actually actively working on including AutoGPT to LangChain, so hopefully soon we can use it in LangChain as well. But now let's just take a look at the code from the GitHub repo. First of all, we need to git clone the repo, and we direct to the AutoGPT directory. You can see what is in the directory. Pip install required packages. So all the packages are listed in requirements.txt. So you just do pip install requirements.txt. There is a file called .m.template where it listed all the API keys, and so the instruction is to rename this to .n and fill in your OpenAI API key. What I did is just like what we did before, we set the OpenAI API key in the environment directly, and then to run AutoGPT, we just do Python AutoGPT. I can use the flag GPT-3 only if you don't have access to GPT-4. Okay, let's run it and see what happens. Okay, so with AutoGPT, you will give your AI a name, or just try the original one. And then you will describe your AI's role. For example, an AI designed to develop and run business with the sole goal of increasing your net worth. Let's just try that. Now you can see it has the thoughts. I need to determine what business moves to make to increase my net worth. And it has some reasoning. Browsing Forbes can provide insights. And then it has a bunch of plans. Browse Forbes website, determine if any of those industries or companies are capable of being replicated. And then we have criticism. I may get lost browsing and lost track of time. So we need to keep track of my time. So the next action is actually browsing the Forbes website with the question, what industries and companies are currently profitable? And now, fail to parse, not sure what's happened, but then let's just enter Y, see what happens. It was actually the next action was to start an agent to do a web scraping on Forbes website. And then it was like, I'm not authorized to perform web scraping. Instead, I will use Google to search for articles. Now the plan becomes search Google for currently profitable industries or companies. Now the next action becomes Google search. I really like AutoGPT that it gives human a chance to say yes or no to proceed. Now I can say yes to authorize the command, and now it's doing Google search. Now the plan is to use a GPT agent to read the information from the top search result. The next action is to start an agent, which is an industry analyzer, to read and analyze information. Okay, let's say yes and see what happens. AutoGPT has identified four profitable industries. I'm not sure if this is the best approach to find the industry first. It's kind of weird. Yeah, so that's the basic idea of AutoGPT. You can have this conversation with AutoGPT forever. You will just keep going and you can keep spending your OpenAI API money. I want to show you some real-world use cases for AutoGPT as well. Here's the first example. It's using AutoGPT to write its own code and execute Python script, which I think is really cool. This one is doing a market research, browse recent events and create podcast outlines, book flights and ordering food. Here's an example of using AutoGPT on your iPhone. AutoGPT has a lot of use cases already. Also, it's quite incredible. Yeah, so that's it for this video. Well, we talked about 4 autonomous AI agents projects. Despite being in their early stage of development, they have already showed impressive functionalities and potential applications. And I'm very excited to see what's going to happen next. Hope you find this video helpful. Thank you and see you next time. Bye!